Welcome to June 19th LeetCode Challenge, K inverse pair array. For an integer nums, the inverse pair of an integer I, j, where I is less than or equals 0, and less than j, less than nums length of nums, and that nums at index I is greater than nums at index j. So, given two integers n and k, return the number of different arrays consist of the numbers of 1 to n such that there are exactly k inverse pairs such that the answer could be huge. Since the answer could be huge, return modulo of 10 to the 9 plus 7. So say we have input of 3 and we have k equals 0, we have a return of 1. So what that means is that we can only make an array of consistent of 3 integers such as 1, 2, 3, which has a number between 1 to 3 in exactly 0 inverse pairs. However, if we enter the same conditions here, but with k equals to 1, we have output of 2. So therefore, we have to inverse the array of 1, 3, and 2, and 2, 1, and 3. And then we have exactly 1 inverse pairs, because these two are inverses of each other. It's kind of like the inverses of each other. So we have n equals k, n maximum bound is 1000, for k is also 1000. So this is designed to be a hard problem. I don't have, to be honest, I had to look it up a bit. So I'm just going to show you kind of my approach and how I kind of thought of it. I knew right away it was a dynamic programming question with some kind of memorization or some kind of storing of cumulative values. But I solved a similar question before using a one-dimensional dynamic programming array. So I think that's kind of my go-to type of approach to this question. So that's how I'm gonna solve this question. So for this type of dynamic programming question, we're gonna make a dynamic program array, a DP array. That doesn't have any rows in it. So what we want to do is, instead of storing it into a two-dimensional array, we just store it in 1 using the previous rows, and then we're going to update it at the 1D array in a temp value, and then if the DP array could be updated with temp at any time the row is finished analyzing it. So then we'll walk through it, and I'll walk through the code and how I kind of thought and reasoned out, and the one I understand how to do. So the first thing we want to do is initiate a DP array of the size, of the size of k plus 1. In order to be, then we want to, of course, note the modulus that we have. So it would be 10 to the 9 plus 7. And the next thing we want to do is we want to run a for loop. So for I in range between 1 to n plus 1, what we're going to do is we're going to initiate our temp variable. So temp is equal to 0 star k plus 1. So this is the same size as our DP array. Next thing we're going to do is we're going to initiate temp at index 0 to be 1. And then from that, we're going to run another for loop. So it's going to be a nested. It's going to be a nested for loop inside now. It's going to be for let's say j in range 1 to k plus 1. What we're going to do is we're going to, if our j minus I value is greater or equal to 0, what we're going to do is we're going to create a assign val to be our DP array at j plus our modulus minus the DP array at our previous index, which is j minus 1, and all that is going to be modulus as well, modulated. Alright. Else, if this doesn't work, what we're going to do is we're going to assign val to be basically all this again, except it fails our assessment, so we don't need to minus anything out of it. And then what do we want to do? We want to reassign temp to be temp at location j, index j, to be temp at j minus 1 plus the value that we're calculating for accumulated so far, modulus again. And then we want to, everything is successful, we want to update our DP array from our temp array. Now what we want to do is, so if k is greater than or equal to 0, we're going to return our DP array at index k plus a modulus minus our dynamic program array at k minus 1, so the previous index of that, and all that should be modulus as well. And then if not, else return same deal, except we don't minus it from our previous index. All right, let's run to see if this works. So finish. It looks like it works. Oh, okay. Let's see. We have a DP assign array is made of that times the size of that. We have our modulus correct for I in range 1 to n plus 1. Make our temp variable assign index 0 to be 1, rather than the for loop j with an index of 1 to k plus 1. So if k is if j minus I index is greater than or equal to 0, we want to assign value to be dp at j plus 1 minus rj at index I. Alright, and else, if that doesn't work, I'll reassign val at index j plus m modulus at assign temp at index j to be temp at j minus 1, yep, plus val dp is assigned back to temp. If k is greater than 0, return dp at k plus modulus minus the k minus 1 val index. Alright, let's submit it. Okay, accepted. So this is a very hard question. So there's tons of solutions on it, how to optimize the double dynamic programming approach. If you were to do this by brute force, the time complexity would be actually big O n factorial times n log n, which I don't even know will be cause a timeout type error, time exceeded error. So I know for this one-dimensional array, the time complexity is big O n times k, because the dynamic program array size is what's called n plus 1 times k plus 1, wherever it is, yep, times k plus 1. So that's once everything is filled out, the space complexity is similar as well, so it'll be big of n n times k. So likewise, the dynamic program array is the size of n plus 1 times k plus 1 space used. Alright, have yourself a nice day.